Hello, I'm Robert Kraft. Welcome to Experiment of the Week. This time we're going to look for rainbows. Nancy and I do a lot of traveling, and along the way we see lots of rainbows. Sometimes it's just a lucky accident, but quite often it's because we went hunting for that rainbow. We found just the right spot at just the right time to see the rainbow as we wanted it for a photograph. How do we do that? Well, to understand that, we need to understand some of the physics of rainbows. And for that, we need a nice sunny day and a garden hose. Take your garden hose to a nice sunny spot like this one, and then you're going to put your finger over the end of the hose to make a spray of water. That spray of water is going to simulate the droplets of rain. Okay, there's our simulated rain, but where's the rainbow? To see that, I need to turn slowly in a circle, watching the water spray until suddenly the rainbow appears. But why does the rainbow only appear at this spot? Is there a buried pot of gold in this part of the yard? What's so special about this direction? For a clue, look at my shadow. My shadow is directly in front of me, which means that the sun is directly behind me. For you to see a rainbow, the sun has to be directly behind you. Why? Well, sunlight's made up of all the colors of the rainbow mixed together to give you white light. When that white light hits a raindrop, some of it's reflected back, but its path is also refracted or bent. Different colors are bent different amounts, so they separate into the colors of a rainbow. So to see that rainbow, you need the rain to be falling directly in front of you, just as the water spray is now, and you need the sun to be directly behind you. That way the sunlight hits the water drops, reflects back toward you, letting you see all those wonderful colors. Okay, so imagine that we're going out looking for a rainbow. Where we look depends on the time of the day. In the morning, the sun is low in the east, which means we would want to look toward the west to see our rainbow. So we would need to move so that the storm was directly to our west. In the afternoon, it would be just reversed. We'd want to be looking to the east because the sun would be behind us, setting in the west. You always want the sun behind you and the rain in front of you to see that rainbow. Another rainbow-like feature that you might see is called a sundog, but it forms in a different way. You'll see it when you're facing toward the sun, usually in high, thin, wispy cirrus clouds. Now, the sundog doesn't form by light reflecting off water droplets. Instead, it forms as light passes through tiny ice crystals floating in the cloud. But it still breaks that light into the different colors, giving you that rainbow-like effect. So once you know how a rainbow works, it's very easy to find just the right spot and just the right place to see a rainbow. Well, that's all for this time. Have a wonderful week. Hello, I'm Robert Kraft. Welcome to Experiment of the Week. This time we're going to go looking for rainbows. Nancy and I travel a lot.